Hello everyone. In this video I will show you how to use the FIFO or first in first out function within the CODESYS. It's not provided by default. As a result, we need to add a library to our project which is called the OSCAT library, and I will show you how to get it and how to add the library into your project. I'm going to create a new standard project. I just call it FIFO, and since I'm going to use CFC as the programming language, I add CFC into the name as well. And here I select CFC. Now we have the project here. As I told you, the FIFO function block is not available within the CODESYS itself. We need to add the library to our project, and you do it through library manager, and then here in the add library we need to add the library to our project, but it's not already it shouldn't be here because I haven't, or no, it's already here. So since in one of the projects I already have added the OSCAT basic library into one of the projects, I can already see it here in the miscellaneous. But if it's the first time that you are going to add the OSCAT library, it's quite straightforward. First of all, you need to get it. To get it, you need to go to this oscat.de website. Over there you go to downloads, and here then you need to press on I accept, go to OSCAT basic, and here in the OSCAT basic you should be able to find the OSCAT basic for CODESYS, which is Syria. So OSCAT basic 331 underline CODESYS 3, and then you can download it, save it into your computer, and then go back to CODESYS. Here in the library manager you need to press this library repository, and over there you need to introduce clicking on install, you will be able to find out the library file that you have saved into your system, and then clicking on open and then clicking on install, you will be able to later you will be able to add the library into your project. Okay, I already had it here. So to add it into my project, I need to click on add library, and in the miscellaneous I have this basic OSCAT. Clicking on it, I will have it in my project. Now I will have access to all the functions which are provided here in the OSCAT init. So I have set of POUs, some global variables, constants, and there are some data types. In this video I'm going to indeed focus on the FIFO. Let me see where it is located, or even we don't need to know the exact location because we know the name of the function. Okay, so we can go back into the program development area, and here I can insert a box. For the box, now I can search for FIFO, and as you can see here we have two function blocks, basic.fifo underline 16 and basic.fifo underline 32. I guess the only difference here is in terms of the number of elements that we can have in the data block, indeed 16 elements or 32 elements. I'm going to select the 16 elements and clicking on pressing the enter indeed. We need to declare an instance of this, and here it is. We can click on OK, and we have it here. So as you can see here, we have couple of inputs and couple of outputs for this function block. The first input is data input, second one is enable, this is of type double word indeed. Enable is Boolean. When it's true, the function block is enabled. This is read, this is write. These are also Boolean inputs, when to read or when to write into the buffer indeed. And this is the reset, and I will show you how this reset works within the example. From here we get the output data, and empty and full show whether our indeed 16 word buffer is full or it's empty. Okay, so now we need to specify the inputs and get the outputs. To do so, I'm going to add a visualization to this project. And then within the project, I'm going to use a slider to determine the input data. And for the input data, I'm going to indeed introduce a variable in data of type double word with the initial value of 0. And I can also have out data double word, and here I just associate this with the in data. Okay, so through this slider I can change the value for the in data. The next thing that I need here is to have this enable and read and write inputs at least, and with reset I can also reset it. So I'm going to from the lamps and switches, I'm going to use a deep switch as the enable, and I guess I can directly associate this with the FIFO .e indeed. So whenever it's true, the function block will be enabled. Whenever it's false, the function block will be disabled. For the read and write, I will use push buttons. Read, make a copy, call it write, and here I need to determine the variable, the tab variable for this. For the read, I just associate it with this RD input of the FIFO, and for the write I associate it with the WD or write indeed. Read data or write data. One more thing that I need here is to bring a progress bar, let's say, for displaying the output value. Output data indeed. So I need to determine the variable here as the out data. One more thing that I need is to have the resetting. And here as the variable I need to determine the reset input. Okay, and I guess now we can just try to see the operation of the function block. Let me just place them here, and now we can try to log in. There are some errors. We have 3 errors: ambiguous namespace, standard. We have some problem in the library manager. Okay, since here with the OSCAT we have this standard library 33010, and I already had the standard library 3590. I guess I need to remove this from my project, and now I have only one standard library. And then now we can try to build the project again. I hope there will be no errors, and indeed that's the case. And now I can run it. So enable is initially true, meaning that the function block is enabled. Changing the value of the slide bar here, I can change the in data, and out data is initially 0. And here for the FIFO instance that we have, you can see that we have data input, enable, read data, write data, reset, data out, empty, and full as the inputs and outputs. And we have this FIFO array as well. And as you can see here, it's an array of 17 values indeed. 0, 1, 2, 3 up to 16. We have 3 other variables as well here. N, which determines the number of elements. It's a constant value, we cannot change it. And here we have the index indeed for reading and writing. Initially they are 0 as well, and now we will see how they change when we start to write data into the FIFO and when we read the data from them. If I click on write, and you should notice that our value, the input data value is we have it here indeed 37. If I click on write, alright, so I forgot to mention something here, and indeed that's a good point. The reading and writing of data into the FIFO happens continuously when the data write or data read inputs are true. For that reason, we need to have triggering. And to have triggering, we need to introduce them into the read and write. Indeed, here we can right click on the input. Let me see if we have them. Here we can negate for the pins. Okay, so it's not possible to directly do it from here, and therefore I need to introduce this rising edge detection indeed. It's called R underline trick. I just declared it here, but you can do it in this way as well. Insert a box, find R underline trick, and you will find it in standard.R underline trick. Clicking on OK, we need to declare it, the variable. We had one, but I'm going to introduce another one as well because I need 2 of them. Okay, for this one I need to change it back to 0, and now you can see that we have these 2 rising edge detectors. I connect the first one to read input and the second one to the write input. And here for the read, I need to change this into R underline trig underline 0 dot clock, the input of the R trig, and also the write as well. But write will be associated with the clock input of the second rising edge detector. So now whenever we press this read or write, there will be a very short pulse generated at the output of the R3_0 or R3_1, and then the data will be moved within the stack that we have here. Okay, now let's try again. Hopefully this time everything will be okay. There are no errors. Initially the input data is 0, changing it to some value, and clicking on write. Let's see what we have in the FIFO. Enable is true. The input data is 0 still. Okay, we need to indeed click on read. Alright, there's some issue here, because each time that I click on write, you see that the index here increases, which is normal. However, we don't see the data appearing here, and that's because, yeah, I just forgot to associate the input D in with the with the in data indeed. Okay, sorry for that. I just go back and change it. So what I need here is to place an input, connect it to D in, and then here I will have in data indeed. Now the input data is connected to our FIFO, and we can try to see whether it's going to appear here within our stack or not, within the array indeed. So clicking on write, you see that the index is increased by 1, and the value that we had here in the in data is written into the array. If I change the value to 27 and click on write again, you see that it is written in the second element of the array. Changing it back to 92, clicking on write, I have it written into FIFO2, some other value 77, click on write, it's written into the array, some other value 46, click on write, it's written into the array, and so on and so forth. So as I click on write, the new value is written into the array, and the index that we have for writing increases by 1. The index for reading is still 0. Now if I click on read, the index increases to 1, and the data output, the DOUT, is set to 70 as well. If I click on read again, the second value that we had entered appears at the output, and if I continue, you see that 92 appears here, 77 appears here, 46 appears here, 27 appears here, and now we have the empty output of the function block set to true, meaning that we have read all the indeed data that was entered or was written into the array. Now if I click on read, the index will not change anymore, and the output data that we have will not change as well. However, if I change the value here into some other value and click on write, the new value will be written, and the index here is indeed continues from the last value that we had. $95. Now if I click on read, we should read 75. I believe, yeah, 75, and then we should read 95, and then again it is empty. The empty output is set to true. And if I click on reset and click on write, okay, I was expecting to have the indexes here set to 0 to start from the beginning, but for some reason this reset didn't work for me. That's something that I can check later and let you know if you can't manage to figure it out on your own. So that's indeed the way in which the FIFO works. Just a minute here. If I set 11 here as the input data, yeah, it continues from here indeed. It doesn't continue from the first location. Anyways, that's some detail that you can go around on your own. One more thing is here is that the element that I have put here didn't work properly, the progress bar, and I guess it's because I haven't associated with the proper data. This out data should be associated with the output of the FIFO, and that's something that I didn't do. So it's something that again you can do on your own. Okay, so I guess that's all for this video. I hope you have learned how to add the OSCAT library into your project as an example of an external library indeed. You should be able to download it, put it into your computer, and then install it into the CODESYS, and then add it into your project. You should have learned how to introduce the FIFO function block into the project, how to determine the inputs and how to get the outputs from the function block, and also how to use this rising edge detectors or underline trick. So thank you for watching, and see you next time as usual.